Chapter 9, Section 6 in the 7th grade note-taking guide is entitled Area of Irregular Figures. So what we're talking about here are composite figures or complex figures or irregular figures. It's really just a conglomeration of basic two-dimensional shapes in part or whole, making up one figure to be looked at as simply one, of which we'll find the area. So they define what a composite figure is here. That's a figure made up of simple geometric shapes. That's a figure made up of simple geometric shapes. You're not going to see anything too outlandish here. Example 1 is probably the most outlandish thing you'll see that you'll have to find the actual area of, and you'll do that by counting instead of actually computing. Really what you're going to see are, a part of a rectangle with half a circle, like the shooting arc of a basketball court. Or you're going to see the a square and a triangle put together to make a house. You're not really going to see anything too odd here that you're going to have to work with to find the area of. Okay, so with that said, let's go ahead and take a look at number 1 here. In number 1, they're asking us to find the area of the figure by estimating. And they tell us here that each square represents 1 yard. So each square is 1 square yard. Alright, so since we're estimating here, I don't have to break this up into shapes and find the area of each piece. I can just find the area by counting the squares and using that to help me figure out things. So what I see here is, as you can see, I've numbered the shape already. We have 46 grid boxes that are basically fully covered. Not quite perfectly, but mostly covered by the shape there. And since remember, area is the number of square units needed to cover a shape, each square that's basically covered is equivalent to 1. Again, we're estimating here, so that number 46, you might look at this and say, well, maybe that box is only half covered. Again, that's really kind of up to you here, but we say there's about 46 boxes fully covered there, so the area is at least 46. Then we see that we've got, as you can see by looking at the arrows, 8 squares that look like they're about half filled. So if we've got half of a full square yard there, that's going to turn out to be 4 square yards that are being covered there. So the area that this wacky shape is covering is equal to 46 square yards plus 4 square yards, half of 8. And when we add that up, we see there's about 50 square yards covered there. So we should say that the shape covers 50 square yards. And again, this is just an estimate here. We're not computing the actual here. We will do that in a second. All right, but here that's just an estimate. This takes up about 50 whole grid boxes put together. And that's all we're going to say here. All right, so let's go ahead and take a look then at number 2. Number 2 is a composite figure that's comprised of a parallelogram and half a circle. And they want us to find the area of this parallelogram with a half a circle shape. Now, of course, the one we want to run right off and do is the parallelogram, because the parallelogram is really the easy one. For the half a circle, we're going to find the area of it like it was a full circle, and then we're going to take and chop that number in half, and that'll give me the half a circle shape that you see there. So they start off here in step 2, as you can see, by finding the area of the easy one, the parallelogram, base times the height. That's why you can see they've got the right angle mark there. So we're going to do 16 times 9 there. 16 times 9 changes into 144. So the area of the parallelogram is 144 square meters. Now, as far as the half a circle goes, the line we have there goes all the way across that half a circle. Well, if it was a full circle, it wouldn't matter. It would still be the diameter there, because it's the line that goes all the way across. Well, I don't want the diameter, I want the radius. So I'm going to take that and chop that in half, which means the radius of the half circle is going to need to be 8. So if the radius is 8 meters, now I'm going to dump that into the formula, pi r squared. And again, after I do that, then I'm going to chop that answer by 2, because that's going to give me the half a circle. So 3.14 times 8 squared, or 3.14 times 64. As you can see, that's listed right down here. That's going to give me 200.96. And again, and then I'm going to take and divide that by 2, multiply by 1/2 is the same thing. And that's 100.48. And I'm going to add these guys together now, my 144 and my 100.48. And that's going to give me 244.48. So the area of the composite figure is 244.48 meters squared. Number 3 is another composite shape. Makes sense since that's the topic here. The Wrights want to tile their entry with square foot tiles. How much tile will they need? So as you can see, their entry there is a little teeny tiny rectangle on top of a trapezoid. So we're finding the area of the rectangle and the area of the trapezoid and adding these together here. Now we're kind of lucky because they're using square foot tiles. If they were using something else, let's say they were using tiles that were 8 inch by 8 inch or 9 inch by 9 inch, we then have to take and convert that into a foot size, or take the foot size of the area we're about to find and convert that into inches, and then figure out how many tiles we can lay in. But since they're square foot tiles here, all we have to do is whatever the area ends up being is going to be equivalent to the number of square foot tiles they need. Because if I'm covering 64 square feet, which I am here, with square foot tiles, then I just need 64 tiles. So let's take a look here. All right. The answer here is the amount of tile equal to the area of the entry. The entry is obviously a composite figure. So we're going to do the same thing we've been doing here. Find the area of each piece and add these guys together. So we'll start with the rectangle. The rectangle is really the easiest one. If we come back up here and look at the top, it's a 5 by 8 rectangle. So they're multiplying together 5 and 8 here, and that's how they come up with 40. Then they're working with the trapezoid. Now the trapezoid, remember the formula is a little more complex here, but the trapezoid has two bases which are the parallel sides. So that's going to be the top and the bottom of the trapezoid as drawn there. So that's going to be the 7 that's listed clearly at the bottom, and then even though there's no number here, we can read to the other side of the rectangle to know that that is 5. So my bases here are 5 and 7. The formula says I'm going to add those guys up. 5 plus 7 is going to change into 12. Then I'm going to multiply that by the height. The height makes a right angle with both those little guys. So that's the little line inside there marked 4. And then I'm going to multiply that by 1/2 or 0.5. So I'm doing half of 4 times 12. So that's the same as half of 48 or 24. So now I'm just going to add the area of the rectangle and the trapezoid together to find the total area here. So I'm doing 40 plus 24, which changes into 64. So the area of the composite figure is 64 square feet, which means in translation then, that we need 64 square feet of tile. Again, the reason that translation is so easy is because they're square foot tiles. If they were 8 inch by 8 inch by tiles or 9 inch by 9 inch tiles, wouldn't quite work that way. We'd have to then translate that into feet to make it work. But because they're square foot tiles, it works out perfectly. All right, so let's go ahead and take a look at the concluding examples here. In number 1, they're asking me to estimate the shaded area. Each square represents 1 square foot. So this is just like the first question here. We're simply estimating the area here. So if we're going to count up how many grid boxes this shape covers, and that's going to help me find the area. Well, as you can see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 whole tiles covered there. So the area is at least 11. And then I've got 1, 2, 3, 4, 5, 6, 7, 8 half tiles covered there. So in other words, 8 half tiles, which is the equivalent of 4 whole tiles. And that's why you can see they've come up with an answer there that's equivalent to 15. They're adding up the 11 whole and the 8 half, which is equivalent to 4 whole, and that's how they come up with 15 square feet of tile. And we're going to skip number 2. The reason we're going to skip number 2 is number 2 is a shape that as drawn we can't compute. What they should have done, and I think what they meant to do, is that this side here should really line up with this side here. It doesn't. So what you really have here is kind of a trapezoid and a part of a square minus a chunk. If these two lines were to line up here, you would have a triangle and a trapezoid and a square that might work. Or if they shifted this line over, you would have a triangle and a square that would work. But as this is drawn, I'm not exactly sure how they came up with this answer, unless they just estimated and said that's close enough. But that's not what we're about to do here. We're not going to start giving out wrong answers here. So we're going to skip this question because as drawn, this cannot be solved. The book has very obviously made a mistake in the drawing process, and I don't know how they've made up for that solution that they've listed there. So let's go ahead and go on to number 3. It says the Franklins went to wallpaper the wall of their daughter's loft, and they want to know how much wallpaper are the Franklins going to need here. So there's a couple different ways you can chop this shape up into things you already know. One option here would be to draw a line across and finish the shape out this way, going left to right. So that means if you did that with a line here, you would end up with a trapezoid and a triangle, which does work, but trapezoid is really the hardest one to work with. It's got the most complex formula. What would probably be better and easier is to drop a line straight down, because if I drop a straight line down, then I end up with a rectangle and a triangle, and that's much easier for us to work with. So that's exactly what we intend to do here. I'm going to go ahead and start solving then. We're going to put these numbers into the formula here. The rectangle over here is 6 by 18. Now some of you might be saying, well, why isn't he using 23? 23 is this whole line. With this line here, I only need it up to here now for this rectangle. So that's why I'm doing 6 by 18 here. And 6 by 18 is the same as 60 plus 48, or 108. So we've got the rectangle figured out there, pegged at 108. All right, as far as the triangle goes now, with the triangle, you've got this little line over here. Now we know this whole line is 23, but I only need this chunk now because I've already solved up to here is 18, which means this little piece has to be 5, because of course my 18 and my 5 is how I'm going to come up with the total line that measures 23. The height, well, I've got this chunk here at 5, and if I read across to the other side of the rectangle, I know this side here is 6. So the height is going to be 11. So the triangle is going to be half of 5 times 11, or half of 55. Okay, well, if I'm chopping 55 in half, 55 chopped in half here is going to give me 27.5. So now to find the composite area here, I'm going to add these two guys up, and I add those two guys up, and I end up with 135.5 square feet. It's going to take 135.5 square feet of wallpaper to cover the space.